So let's head over to the Excel sketches, the Arduino sketches, sorry. Okay, here's my Arduino sketch folder, and there's those two folders which were installed. Let's try the basic one first. So here we have a sketch, basic INO. Okay, loading up the IDE. It's always a slow process, this one. Okay, here we go. Let's maximize this window. Okay, so here we have some hard to see comments. Let me just remove that comment functionality here. Okay, so right, we got a date here, 2016 July. Okay, it's in the public domain. Thank you, Roberto. Okay. Right, so let me just reinstate that comment. So here we go. There's that rxl.h, the header file. It's being included in this sketch. And here we have some variables, an index number, IDX, timing information here. There's the input from analog 0 on the Arduino. It's a floating point number. And here we have a random number. That was, I think, the blue part of the charts in the Excel spreadsheet. Okay, so what's this? RXL, my Excel. Okay, so this, the instructions for what are the RXL object are is included inside of this header file. So this instruction here really is saying, okay, read the template for the RXL object and create that object and call it my Excel. So we've made the physical object, if you like, from this template. Okay, it's called making an instance of this object. So we've got this new thing called my Excel. You sometimes see the same thing with servo motors. You see like commands like servo, my servo. So servo was the template, and my servo is the object that you've created for you to manipulate. So a very similar thing here. Good old setup function. We're setting the baud rate, so it's 115/200, and we have a delay built in there, usually just to enable the communications to go ahead smoothly. I'm not going to go through all of this stuff, but in fact I'm probably just going to zoom down to the more usable parts of this code. Okay, so here it's doing some processing. It's reading the analog signal. Okay, and it's a 10-bit analog to digital converter. So each bit of the signal is kind of split into just over 1,000 parts. So this is scaling it up to 5 volts. Don't put more than 5 volts into your analog inputs. You might fry the Arduino. And here's just some function just to give some data for the random variable. This random variable was used just so that the chart was jumping up and down, so you could see that, you know, something's communicating with the sketch, the Arduino sketch. So here we go. Here we have some lines of code which are written to the spreadsheet. Okay, so it writes example, has a cell number, so B5. It's going to write the data, the value for the analog input, to 2 decimal places. So here we also have a write command for the another example, B6, and that corresponds to the random and the value of the random number, and also to 2 decimal places. So this is not too bad. We've got 2 bits of data which we can read at the same time. We could add another one, so we could just copy and paste this line. Okay, if we have like 3 sensors on there, and we need to get 3 bits of input at the same time, you know, we could simply have make an adjustment here. So we just have this variable sensor number 3. Of course, we'd have to go up here then and initialize that. So we'd have something like float my sensor 3. Can I just copy and paste that? No, I can't. Okay, so my sensor number 3. Okay, so then we've created this variable. We told it's a floating point, and this should write in cell number B7 of the spreadsheet the value of this, whatever it is. So obviously we have to make another kind of input pin on the Arduino somewhere. Where do we have that information? I'm not entirely sure. I haven't gone through the sketch for a while, but well, here. Okay, so if we wanted to, we could just have our third sensor here. Let me just copy that name. Float. Okay, analog read. Maybe we could have an analog sensor on pin 1. I'm just basically kind of giving you the lowdown on how to get a third sensor up and running. Okay, I'm going to actually remove this because I'm not interested in a third sensor at the moment. So let me just go back up here. If I don't use this variable, is it going to cause me a problem? Maybe not. But delete it anyway. And this line here, okay, let's delete that. Okay, so that's the basic sketch. It should just dump 2 bits of information into the Excel spreadsheet. So let's upload this. I'm going to connect my Arduino now. Okay, cable's in. The Arduino lights are flashing like crazy. It means it's okay. It's steadied down now. It's ready. So which COM port is my computer putting it on? It's putting on a COM3. If you don't know which COM port your Arduino is, you might have a list of COM ports here. Press the Windows and X button on your keyboard at the same time. So hold down the X, hold down the Windows button, click X, and then you should get a menu coming up. Select Device Manager. After some time, you should have an option saying ports if your computer recognizes the Arduino. I'm assuming you've already installed your Arduino. So here it gives you the information as to which COM port it's on. It's allocated COM3. My Arduino is a clone. It has the CH340 serial interface communications chip on it. Okay, so it's in COM3. So you can read the number here as to which COM port that you're using. Okay, the baud rate was 115,200. Okay, so that's the basic sketch. I'm going to upload it now to my Arduino. Hope it doesn't take too long. Come on. Okay, it's one of those days where it seems to take forever to upload the sketch. Okay, you're getting some information. Please disappear. Okay, thank you. Right, so my sketch is working. I actually have a potentiometer connected to my analog 0 pin, and I'll give you the diagram for that. So if you open up one of the example sketches from the basics, if you open up the sketch analog, read analog voltage, there's a link here inside that sketch which contains the diagram of the circuit that I'm using. So I'm going to close this now, go back into my browser, paste that Arduino link in there, and here we have a page on the Arduino CC website talking about reading analog voltages. Now I'm actually using this circuit. I just have a pot. One side of the pot is connected to 5 volts. The other extreme side of the pot, the black line, is connected to ground, and the middle pin is connected to my A0. And as you know, with a potentiometer, there's a kind of slider in here, or a wiper. So if the wiper is kind of towards this side, then 5 volts will almost be flowing through your potentiometer. Okay, if you move the slider by turning the spindle, so the slider can move down here, it's closer to the 0 volts, so your voltage will go down. What's happening is a little bit of voltage is coming through here, and it's passing through the resistance path in the potentiometer, and as the slider moves down there, you get a lower and lower and lower voltage. When the slider is completely over there, you should get 0 volts. When the spindle is turned towards this direction, you should get almost 5 volts. So that's the circuit I'm using. Okay, here's the sketch again. Let's go back now into the Excel spreadsheet, because I've uploaded the sketch. My potentiometer is actually already sending data through the serial port, but I'm not recording it yet in the spreadsheet. So let's go back to the spreadsheet.